Welcome back to the Deep Dive. Today we're diving into a question that probably keeps some philosophers up at night, and that's how we understand so much more than what's literally said.
We go so far beyond the dictionary definitions of words.
Yeah, and that's the realm of linguistic pragmatics.
Specifically, we'll be looking at conversational implicature.
Right, so think of this as a deep dive tailored for a philosopher. Like we're going to be focusing on the core logic and reasoning behind all of this.
Exactly.
So in this deep dive, our mission is to unpack two powerful frameworks that can give us a formal way to understand these implied meanings.
We'll be looking at optimality theory and game theory, drawing on the insights from the Stanford Encyclopedia of Philosophy.
Okay, so to kind of kick things off, let's revisit Paul Grice and his idea of conversational implicature.
Right, so Grace's key insight was that communication is not just about decoding the semantic meaning of sentences. It's more nuanced than that.
It is.
Because we're rational and cooperative beings, that very cooperation drives us to infer much more than what's explicitly said.
Right, so like if I say John or Mary came to the party, you would naturally infer that not both of them came.
Exactly.
And that not both isn't really part of the strict logical meaning of or, but it's a conversational implicature we routinely draw.
And as Grice pointed out, this kind of inference happens because you, as a listener, assume that the speaker is following certain cooperative principles.
Right.
For instance, if the speaker knew both John and Mary were there, why wouldn't they have just said so?
Yeah.
Their choice to use that weaker statement, it signals something about their knowledge.
It does.
So that brings the reasoning of both the speaker and the hearer into play.
Exactly. And for this deep dive, we're focusing on generalized conversational implicatures. So these are the implied meanings that tend to arise kind of fairly automatically based on the conventional semantic meanings of the words.
Right.
Okay, so let's jump into the first framework.
Let's do it.
Bidirectional optimality theory. BIOT, as it's often called.
Yeah. So optimality theory, or OT, in linguistics, proposes that many linguistic choices arise from a kind of competition. Imagine a speaker has several ways they could express a certain idea.
Right.
OT suggests they'll choose the expression that best satisfies a set of general principles or constraints. Think of them as rules of communication we generally follow.
Okay.
Now, when OT was first applied to meaning, the idea was that when you hear an utterance, you consider various possible interpretations. And the interpretation that wins out is the one that best aligns with those general preferences or constraints.
Right.
But then a linguist named Reinhard Blettner came along, and he extended this idea with bidirectional OT, or BIOT.
Okay.
His key insight was that we also need to consider the alternative expressions, the other ways the speaker could have phrased the message but didn't.
Right.
This brings the speaker's intentions and choices into the picture, which is really important for understanding how we get those extra layers of meaning.
I see. So BIOT isn't just about the best way to understand what was said, but about finding the best pairing of a form, like the words used, with an interpretation, what was meant.
Exactly.
And Blettner introduced the concept of a strongly optimal pair. What does that mean?
Okay, so a form interpretation pair is strongly optimal if it meets two conditions. First, from your perspective as the hearer, the interpretation must be the most natural or likely one given the form.
Okay.
No other interpretation should be more obvious or stereotypical for that expression. Second, from the speaker's perspective, the form must be the best way to convey that interpretation. That means there's no other form that could have made that meaning any clearer or would have been less complex to use. So BIOT looks at meaning from both sides.
I see. So it's a two-way street.
Exactly.
So let's look at how we interpret numbers. The text mentions that the semantic meaning of two children came could be argued to be at least two children came.
Okay.
But we almost always interpret it as exactly two children came. So how does BIOT shed some light on that?
Right. So imagine the speaker could have said 1, 2, 3, or even 4 children came. And let's simplify things a bit and say the possible interpretations are exactly 1, exactly 2, exactly 3, exactly 4.
Okay.
Now let's think about probabilities. If someone says 2 children came, the probability that they meant exactly 2 is higher than if they had said 1 child came, given that at least 2 is true. So that interpretation, exactly 2, becomes strongly optimal for the form 2.
Right, and that connects back to the text where it's talking about those strongly optimal pairings, right?
Yeah.
Where 1 gets paired with exactly 1, 2 with exactly 2, and so on.
Precisely. The interpretation exactly 2 is strongly optimal for 2 because, given the form, it has a higher likelihood of being the intended meaning than other possibilities.
Wait.
And if the speaker meant exactly 3, they likely would have used the form 3, which has an even higher probability of conveying that meaning.
Right.
So that blocks other interpretations for the original form too.
That makes sense for linearly ordered meanings, like numbers. But the text brings up a more complex scenario. Non-linearly ordered meanings, such as John came versus John or Bill came. What happens there?
You're right. That is a really interesting point. Because if we consider the possible situations to be only John came, only Bill came, and both John and Bill came, and we're analyzing John or Bill came, BioT initially seems to have a problem.
Right.
Why use the less specific John or Bill came if you know for sure that John came? It seems like each possible interpretation could be better expressed by one of the simpler statements.
So why doesn't that happen? We understand John or Bill came to mean that the speaker isn't sure exactly who came, or at least isn't committing to only one.
You're exactly right. So to
Yeah.
resolve this, Maria Aloni suggests that our interpretations need to account for the speaker's knowledge. Saying John or Bill came often implies a sort of ignorance on the part of the speaker.
Oh,
Like
yeah.
they don't know if it was John, Bill, or both. So by incorporating these ignorance implicatures into BioT, we get a more accurate picture. And interestingly, the predictions that BioT makes when it considers ignorance implicatures actually line up with formalizations of Grace's maxims of quality and quantity that were developed by Schultz and Van Rooij.
So both approaches lead to similar conclusions.
Exactly.
Okay, so now let's switch gears and talk about Horn's division of pragmatic labor, sometimes called M-implicatures.
Okay.
What is that all about?
Okay, so Horn's division basically highlights this fundamental tendency we have in how we use language. Simpler, more common ways of saying things, which are called unmarked expressions, tend to be associated with simpler, more typical interpretations.
Okay.
These are also called unmarked interpretations.
Okay.
Then you have more complex or less frequent expressions or marked expressions.
Right.
And those tend to be associated with non-typical or marked interpretations. And a key thing to remember here is that there's always the availability of a simpler alternative expression.
The classic example the text mentions is the difference between John killed the sheriff and John caused the sheriff to die.
Exactly.
We automatically understand the first, more direct sentence as implying an intentional killing. And the second sentence, which is more complex, suggests a more indirect or maybe even unintentional death.
That's exactly right. And Blutner demonstrated how BioT can explain why the unmarked form, John killed the sheriff, gets that stereotypical interpretation. It's less complex, and the direct intentional act of killing is the more typical scenario.
Okay.
So BioT predicts this strong pairing through the principle of strong optimality.
Right. But the text points out that strong optimality alone doesn't fully explain why the more complex form, John caused the sheriff to die, gets the non-stereotypical interpretation. If both sentences mean roughly the same thing, why don't we just go with the typical killing interpretation for both of them?
Well, that's where Blutner brings in the concepts of weakly optimal pairs and the idea of blocking. So a form interpretation pair is considered weakly optimal if it isn't blocked by a more strongly optimal pair. Blocking happens in 2 ways.
Okay.
Either there's a strongly optimal pair with the same form but a different interpretation, or there's a strongly optimal pair with the same interpretation but using a better or usually simpler form.
So how does that explain the sheriff example?
Okay, so the stereotypical interpretation of intentional killing is strongly associated with that simple form, John killed the sheriff. That strong pairing actually blocks the stereotypical interpretation from also being optimal for John caused the sheriff to die.
Right.
So then the pairing of the more complex form with that non-stereotypical, meaning the indirect or unintentional death, can still be optimal in a weaker sense because there isn't a strongly optimal pair directly competing with it.
I see. The more elaborate phrasing is what signals that deviation from the typical.
Exactly.
Okay, so we've seen how optimality theory can explain those implied meanings. Now let's look at our other tool, game theory.
Okay, so game theory offers a different but also very interesting perspective on communication. It views it as this strategic interaction between rational agents.
Okay.
Peruk's work in the late 1980s was very influential in applying game theory to language. He focused on how people make choices when they don't have all the information. There were also some earlier attempts to explain Grice's maxims using game theory. What we'll focus on here are the approaches that use signaling games and iterative reasoning.
Okay.
And it's worth mentioning for philosophers that there are definitely connections between optimality theory and game theory, which has been explored by researchers like Decker and Van Roy and Franke and Jaeger.
Right. Now, signaling games, which were initially developed by David Lewis, were about how communication can even happen with signals that have no inherent meaning.
Right.
So how do we adapt that to pragmatics, where words already have set meanings?
So in pragmatics, when we use signaling games, we assume the messages, meaning the words and phrases, already have a conventional semantic meaning.
Okay.
And Pilark's adaptation often uses what's called games of partial information, where we also assume the speaker is trying to be truthful.
Okay.
So these games are basically a simplified model of a single instance of communication happening within a specific context.
Okay, so what are the main things we need to consider when we're setting up one of these pragmatic signaling games?
Well, we have a sender, which is the speaker,
Yeah.
and we have a receiver, which is you, listener. And then there's a set of possible states of the world that the speaker knows about, but the listener might not.
Okay.
Then you have the set of possible messages, which are forms, each with their own semantic meaning.
Right.
You can think of that meaning as a function that tells us in which of those possible states the message would be true.
Okay.
The sender then has a strategy, which is a rule for choosing what message to send in each possible state.
Uh-huh.
And the receiver also has a strategy, which is a rule for interpreting each message,
Right.
basically deciding which state of the world is most likely given the message.
Right.
And crucially, we have utility functions for both the sender and receiver.
Okay.
And these represent what each party is trying to get out of the communication, which is often assumed to be the same thing.
Okay.
This reflects Grice's cooperative principle. The utility depends on the actual state of the world, how the receiver understands the message, and sometimes even the form of the message used.
Okay.
And finally, there's usually a probability distribution over the possible states, representing what's more or less likely.
Okay. So the purpose of these games is to model how we figure out the meaning of what's said, taking into account things like what the speaker knows, what else they could have said, and what's relevant in that context.
Right, and the typical solution used in game theory is the Nash equilibrium.
Okay.
In signaling games, it's a pair of strategies, one for the sender and one for the receiver, when neither one can improve their outcome by changing their strategy. It's like a stable point where the sender is choosing the best message and the receiver is interpreting it in the best way, given how they expect the other person to behave.
Makes sense.
Of course, there are more refined versions of Nash equilibrium and other solutions from things like epistemic and evolutionary game theory,
Okay.
but the core idea is the same.
Okay. So let's go back to Horn's division. How does game theory help us understand those implicatures?
Okay, so Parikh's game-theoretic account of Horn's division often looks at a scenario where there's an ambiguous message. It could have a typical meaning or a less typical one, with the typical one being more probable.
Okay.
And there's also an unambiguous message that points to the non-typical meaning, but this message is more costly or complex to use.
Right.
The sender's goal is to communicate the true state of affairs, and their payoff is higher if the receiver interprets it correctly, minus any cost associated with the message. So the idea is to show that there's a Nash equilibrium where the simpler message gets used for the typical situation, and the more complex message is reserved for the non-typical one.
But the text mentions a problem. There might be another Nash equilibrium where the simple message gets used for the non-typical situation. So how do we make sure we get the right equilibrium?
That's where those refinements come in. Parikh argued that the equilibrium we want is usually predominant, which means it's better for both the sender and the receiver than the other equilibrium.
Okay.
Van Ria explored this from an evolutionary game theory perspective, suggesting that Pareto optimal solutions are more likely to stabilize over time. He also suggested using forward induction, which is a fancier way of thinking about the implications of a speaker's choice, to pick the right equilibrium. And Frank's work in epistemic game theory shows how the listener's beliefs can change based on the message they get, which leads them to the right meaning through reasoning.
Okay, so let's talk about quantity implicatures, like how 3 usually implies exactly 3, even if it technically means at least 3.
Okay.
How does game theory explain those?
So quantity implicatures usually depend on the logical relationship between the different things the speaker could have said.
Okay.
For example, 4 is logically stronger than 3 if they both mean at least. Game theory includes the semantic meaning in 2 ways. One is to restrict the strategies to only truthful ones. So they can only use messages that are true and interpret them based on their semantic meaning. Under that rule, we have iterated admissibility,
Okay.
which basically involves getting rid of strategies that aren't as good. This has been shown to justify quantity implicatures.
Okay, so what's the other way that semantic meaning is included in these models?
The other way is to use the semantic meaning as a starting point for reasoning. This is seen in models like optimal assertions, iterated best response, and probabilistic models. The basic idea, going back to Grice, is that speakers try to be informative and relevant, and listeners know that.
Right.
The text has a good example of iterated best response reasoning with numbers.
Yeah, can you walk us through that again?
Sure. So imagine 4 situations. 1, 2, 3, or 4 children came. And we have 4 messages. 1, 2, 3, 4, meaning at least that many.
Okay.
Now imagine a literal interpreter who just takes the basic meaning and thinks all true situations are equally likely. A first-level Grecian speaker, knowing this, will choose the message that makes it most likely the interpreter will understand correctly. So if they know 3 children came, they'll say 3, because that means the interpreter will consider 3 or 4, which is the most likely. A second-level Grecian interpreter, hearing 3, will think if they knew it was 4, they would have said 4, so it's probably 3.
That's how we get the exactly meaning.
Yeah.
The text also mentions how this has been expanded on recently.
Right. So now we're using things like probabilistic choice functions, which better reflect how people actually behave.
Okay.
And there's work looking at uncertainty about word meanings and the shared knowledge between speakers. And we're expanding these models to include more than just generalized implicatures. Things like particularized implicatures, which depend on context, explicatures, which are things that are part of what's said but not explicitly, presuppositions, and even politeness.
Wow.
These game theory approaches are also being used in fields like natural language processing and sociolinguistics.
That's really cool. It's amazing how these complex theories are evolving to explain the subtleties of communication.
I agree. Both bidirectional optimality theory and game theory are great tools for understanding how we communicate so much more than just the dictionary definitions of words. They give us models of the reasoning we use as speakers and listeners.
And it's amazing to see how these frameworks have been built upon over time, using ideas from different areas like epistemic logic, evolutionary dynamics, and probabilistic modeling. So for our listeners, you now have a deeper understanding of these sophisticated approaches to meaning. It's like a philosophical exploration of how we communicate.
And maybe this leaves you with some questions like how could we use these models to understand other forms of communication, or when might they not work so well?
Those are great questions to think about. Thanks for joining us for this deep dive. Until next time.